Dear friends, welcome to my video. Kindly click on the CC button for subtitles. Electron experiment quantum physics. The intriguing world of electrons, an experiment in quantum physics, also known as quantum mechanics, presents a dramatically different worldview than classical physics. It unveils a reality where tiny particles like electrons do not behave according to our conventional understanding of reality. Let's take a journey to the heart of one of the most fascinating realms of science as we delve into an experimental scenario involving electrons. Quantum behavior of electrons. Before exploring the experiment, we need a rudimentary understanding of electrons' behavior in the quantum world. In contrast to classical objects, electrons exhibit dual nature. They can act both as particles and waves. This mysterious trait is a cornerstone of quantum mechanics, known as wave-particle duality. Another oddity of quantum mechanics is the principle of superposition. An electron doesn't have a definitive state until we measure it. Instead, it exists in a superposition of states, meaning it can be in multiple places simultaneously. Lastly, quantum entanglement is another bizarre yet fundamental aspect. This refers to a phenomenon where particles become interlinked and the state of one instantly affects the other, regardless of the distance between them. The double-slit experiment, a quantum showcase. Now let's explore these principles through a modified version of the iconic double-slit experiment. Suppose we set up a device that fires electrons one by one towards a barrier with two slits, with a detection screen behind the barrier. According to classical physics, each electron should pass through one slit and form two distinct patterns on the screen, right? Surprisingly, that's not what happens. When we do not observe which slit the electron passes through, an interference pattern forms, similar to waves overlapping in a pond. This happens because each electron, in its wave-like form, passes through both slits simultaneously and interferes with itself. This manifestation of wave-particle duality and superposition is genuinely counterintuitive. Observation and the collapse of superposition. Here comes another twist. If we place detectors by the slits to determine which slit the electron passes through, the interference pattern disappears. Instead, we see two distinct clusters on the screen, suggesting the electron has passed through one slit or the other, not both. This is known as the collapse of the wave function or superposition. It suggests that the act of observation changes the outcome of the event, a concept that remains one of the biggest mysteries in quantum mechanics. Quantum entanglement. Einstein's spooky action. Quantum entanglement can be illustrated with another experiment. Suppose we have a pair of entangled electrons. We measure the spin of one electron and find it spinning upwards. Instantaneously, we know the other electron, no matter how far, is spinning downwards, without having to measure it. This happens faster than light, which led Einstein to describe it as spooky action at a distance. The quantum world and beyond. These experimental observations challenge our traditional understanding of the universe and how things operate. Quantum mechanics shows us that at fundamental levels, nature is not as deterministic as classical physics would have us believe. It is full of uncertainties and apparent paradoxes. However, these perplexities also open doors to fantastic new technologies, including quantum computing, quantum cryptography, and quantum teleportation, which could revolutionize our world in the near future. As we continue to grapple with these profound ideas, one thing remains clear: the quantum world is far stranger and more fascinating than we could have ever imagined. As the exploration of quantum physics progresses, we can only wonder what other surprises await us in the heart of the quantum universe. Thank you for watching my video. Kindly subscribe to my YouTube channel and give a thumbs up. Thanks for your support.